Hello guys, welcome back to my channel. A very good morning to each and everyone. So today in this session I'm going to tell you all about the topic probability, and I am going to discuss some of the important models and solved examples for you. So let me introduce the probability. So probability is the thing where the chances of getting some event. So before going into the problems, let me introduce some of the introduction. So there are pack of 52 cards. So cards problems are very important in case of probability. So if there are pack of 52 cards, these 52 cards are divided into some ratio, that is 26 and 26. So blacks and reds. So black has 26 and red has 26. Now in black 26 we have again categorized into two. There are 13 clubs and 13 spades, and in red there are 13 hearts and 13 diamonds. So in each suit in the sense in each club and in each spade is a suit. So in each suit there are one ace, and there are ace in each suit. There are ace, twos, threes, fours, five, six, seven, eight, nine, tens, jacks, queens, and kings. So in each suit in the sense which I have already told you, one club, these 13 spades, clubs, and these 13 hearts and these 13 diamonds contains these all aces, 2, 3, 4, and jack and queen and king. So this is how this table is categorized into. So please do remember this table very well to solve the problems on cards. So let the definition of the coming to the definition of the probability here. The definition is, in an experiment is performed, if an experiment is performed n in the number of executive cases and m is the number of favorable cases, then the probability we can define as, that is, this is the formula where we will use in the entire probabilities chapter. So this is very important formula. We can say number of favorable cases by number of exhaustive cases. That is, favorable cases are the cases which a particular case from a particular case which has happened. So that is n of a by executive cases are the sample space. We will also discuss what is sample space and what are the particular case or like n of a in the coming problems. You will understand it better. So for time being, let's move on to the problems first. So coming to the first problem, find the probability of getting one red king if we select a card from 52 cards. So from 52 cards, there are total of 52 cards, right? But it they are asking for a particular card. So let us forget about that particular card for a while. Now there are pack of 52 cards, right? From 52 cards there are two red kings, right? Isn't it or not? There are two red kings from pack of 52 cards. So see, this is 52 cards, right? Here are the 52 cards, right? So in each club, in each spade, in each heart, and in each diamond, there will be a king, right? So from red there will be two kings, right? So this is how you got two kings. So now going to the problem, the same thing is here. See, there are two kings, there are two red kings. So number of possible cases, that means how many kings are present in the pack of 52 cards. There are only two red kings present in the pack of 52 cards. So that is the possible case of 2. And number of exhaustive cases, which means the total cards or the entire card is 52. So this is the formula we have already learned from here. So number of favorable cases by number of executive cases brings 2 by 52. So probability always have to be in least terms. So you need to cancel it. So after getting cancelled, your answer is 1 by 26. Now going to the second problem. Find the probability of getting a head in tossing a coin. See, when a coin is tossed, you will notice that it may get head or a tail. So there is an executive cases of getting two in total, right? But only getting exactly the particular head, you have only one chance. So that is the possible case is one and the total cases are two. So number of exhaustive case, number of favorable cases by exhaustive cases is nothing but 1 by 2. So that is how you will get the answer for that. Now coming to the third one. Find the probability of getting one head in tossing two coins. So let us imagine of tossing two coins. When you toss two coins, first what is the sample space you will get? You may get, see here, the sample space we can write as after tossing two coins you may get both heads, head and head, HH, or one head and second one is tail, HT, or one tail and second one is head, TH, or both the coins may turn into tail, TT. Now you will, so that is the sample space how you will encounter, that is the total space. Now they are asking only for particular one head. Okay, so one head, at least one head. That means from this whole sample space you can take that particular thing as A. Let A be the event of getting one head. So one head means HT or TH. That is one head. Again HH is not a one head. It will come under two heads. When they ask at most head, then you will take HH also into the particular A. So they are asking only one head. So one head have to be. That is like H or head or tail, tail or head, anything that matters. So there are only two particular such cases from four cases. So number of favorable cases where number of executable cases comes 2 by 4. So always probability have to be in least. So you will get you will cancels. Now coming to the fourth problem. Find the probability of getting a sum of 9. 9 if two dice are thrown. Imagine two dice. One dice have 6 faces, right? And the other dice have another 6 faces. Now, imagine of getting the sum have to be 9, it seems. That adding the score of one die and the score of second die have to come the 9. So let us take the sample spaces, how many they are. It may be, let's forget about the 9 first. Let's take the sample space, like how many ways that the two dice can be after throwing. It may get 1, this may get 1 at a time, or this may get 1 and this may get 2, this may get 1 or this may get 3. So likewise there are 6 until 6 and 6. So these are all the favor sample space. The without beyond this there is nothing else that can be displayed when drawing two dice. So these are the only things will be described or displayed when you throw two dice. So now coming to the sample space is over. Now coming to the sum of 9. So from this, where do you find the sum of 9? You can pick whatever which comes sum 9. So 3 and 6. 6 plus 3 is 9. And 4 and 5. 5 and 4. 6 and 3 gives 9. So the sum of the two numbers gives 9. So we have selected those numbers. So these are the particular set. If event of the A is, it is the event of A getting sum is 9. So these 4 and these 36. So these are the favorable cases and these are the exhaustive cases. So after finding it, you will get the answer 1 by 9. Fifth one. If 3 coins are tossed, so till now we have seen only 2 coins. Now it is 3 coin. Third coin is also added, right? Find the probability of getting first one. 3 heads. So first problem we are looking into is let A be the event of getting. So first forget about the particular event. Let's write the sample space first. Sample space is what we have tossed the 3 coins. It may get 3 heads, head, head, head. It may get head, head and 1 tail. It may get 1 tail and 2 heads. And it may get head, tail, head. It also can give head, tail, head. And these are all the possible cases when we toss 3 coins at a time. So first you will write all the possible cases which is under sample space, and now coming into the point where we have to get 3 are heads. All the 3 have to be heads. There is only one chance, that is head, 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 head. So number of favorable cases by number of exhaustible cases is the formula. We will get 1 by 8 as a answer. Now coming to the second one. Second one is what? 2 are heads. So from the sample space, which are the 2 are heads? Head, head, tail, this one, and tail, head, head, this one, and head, tail, head, this one, and that's all, I think. So those will be the, let B be the event of getting. You can imagine, you can take any alphabet for that matter. Let B be the getting of 2 heads. So these are all the things. So 8 will remain as it is because the sample space will not change for any matter. So 3 by 8 is the answer. Next one is the third bit is no head and no tail. No head. No head, it seems they shouldn't be any head from the sample space. So again, taking under consideration of the sample space, there should not be any head, it seems. So there will be only tail, 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 tail in that case. So C be the event of getting no tail, then it will be the answer is 1 by 8. Now coming to the sixth question. Find the probability of getting 2 diamonds if we draw 2 cards. If we draw 2 cards at random from a pack of 52 cards. So forget about the 2 diamonds first. There are 52 cards in total, right? There are 52 C2 ways to choose 3 cards. As of now, I think you all know about the combinations, permutations and combinations. I think it will get into. So from choosing 2 cards from a pack of 52 cards, you have 52 C2 ways. So how to find 52 C2 means 52 into 51 by 2 into 1. This is how you will find. If it is 52 C3, then you will get 52 into 51 into 50 by 3 into 2 into 1. Okay, this is the way you have to find the 52 C3s or 52 C2. How it will work it out is this. Now coming into the topic, so 52 C3 value is this one. Yeah, 52 C2 value is 1326. So now coming into the particular thing which they have given in the question is, there are 13 C2 ways to choose 2 diamonds. So we have to choose 2 diamonds. So from 13 diamonds, there are 13 such diamonds, right? 13 diamond suit, which we have already discussed in the starting of the class. So from 13 we have to choose 2 diamonds. So there are 13 C2 ways to choose 2 diamonds since there are 13 diamonds, right? Now number of possible cases 13 C2, of course. So this 78 by 1326 gives the answer. So number of favorable cases by number of exhaustive cases again. So that's the logic in it. Now going to the 7th problem. It is also again card problem. Let's see how it will work. These cards, 3 cards are drawn from a pack of 52 cards. 3 cards are drawn from a pack of 52 cards. So there are 52 cards in which you have to select 3 cards. So it will take 52 C3 ways to select 3 cards. So that will be your exhaustive cases. See. So 52 C3 is nothing but 22,100. Okay. Now coming to the number of possible ways. What they gave us to find the probability that 3 are spades. There are how many spades in each suit? Each suit itself contains, there are 13 spades. So from 13 spades we have to select 3 cards, right? So 13 C3. That's all there is. So this will be the exhaustive cases and this will be the favorable cases. You will divide it and you will get the required probability. Now coming to the second, first one is over. Second bit, 2 spades and 1 diamond. So the sample space, this number of exhaustive cases will not change at all. It will remain for every bit. Only the thing is, only the possible ways will be changed. See, this will be the same and the number of possible ways is 2 spades. That means 13. From 13 cards we have to select 2. So 13C2 into, from 13 diamonds we have to select 1. So 13C1. So this will be the answer. After dividing you will get this. Now the third sum, third bit, 1 spade, I think that is spelling mistake, 1 diamond and 1 heart. So 13, from 13 spades we have to select 1 and from 13 spades 13 heart we have to select 1 and 13 diamond we have to select 1. So 13C1 into 13C1 into 13C1 is the thing, and the exhaustive cases will not change. So this is how you will get. Now going to 8th problem. So coming to the 8th problem, 3 light bulbs are chosen at random from 12 bulbs, of which 5 are defective. So there are 12 bulbs. We have to choose 3 bulbs in which 5 are defective already. Find the probability that all are defective, 1 is defective and 3 are defective. So let's see how it will work. First we have to find the number of exhaustive cases. So we have to select 12 from 12 bulbs. 3 have to be selected. So 12C3. This is how we will select. And number of possible cases that all are defective. So that 3 balls have to be defective. So from 5 you need to select 3. So this is how you will divide, you will get the required probability. Now the second one, this exhaustive case will not change. 220 will be remains the same for every bit. So number of possible cases to get 1 is defective. So you from the 3 balls which you have selected, you should get 1 is defective and 2 are good bulbs. So 1 have to be defective. So that 1 have to be selected from this 5. So 5C1 into the remaining 7C2. From the remaining 7 you need to get the 2 bulbs which are of good condition. So from the defective bulb you have to get one defective bulb, because in the question they have mentioned one is defective, you have to select it from 5. So 5 have defective, so from that 5 you have to select 1. So 5C1 and the remaining 7 are the good ones. From that good ones you have to select 2. So 7C2. So number of favorable cases by number of exhaustible cases is 105 by 220. Now the third one is 2 are defective. So from this 5 you need to select 2. So 5C2 into, from the remaining 7 good bulbs you need to select 1. So 7C1, 70 divided by 220. So that's the about 8th problem. Now going to 9th one. 2 cards are selected at random from 10 cards numbered 1 to 10. Find the probability that the sum is even if the 2 cards are drawn together and the 2 cards are drawn one after the other with replacement. Here you have to have the difference between what is with replacement and without replacement. With replacement means if you draw one card, you need to draw it and you need to put the card into the pack of cards again. But without replacement means you shouldn't put the same card back into the pack of 52 cards. You should take it over. So that's the difference between with and without. Now the solution. Number of exhaustive cases. So selecting 2 cards from the pack of 10 cards 1 to 10 is 10C2 of course, right? So you will get a 45. The sum is even if both are odd or both are even. You have to find this, both the sum have to be even. See, both the sum have to be even, they have told you. So if you add up any 2 even numbers, you will get even number. If you add up any 2 odd numbers, you will get again the even number. So let's see how it will work. Both are even cases. 5C2, that is 10. If both are odd cases, 5C2, that is 10. So number of possible cases is 10 plus 10. Here or. So you will add it up. So 20 by 45. Okay. 2 cards are drawn one after the other with replacement, means 10 into 10 is 100. Number of exhaustible cases. Number of possible cases, both are even, means 5 into 5, that is 25, and both are odd is 5 into 5, 25. Again plus really. Required probability gives 50 by 100, that is 1 by 2. Okay. Now going to the last problem of this session. A bag contains 5 red balls, 8 blue balls, 11 white balls. Okay. 3 are drawn together from the box. So find the probability that 1 is red, 1 is blue and 1 is white. So let's see how it will work. Number of exhaustible cases. So total 5 plus 8 plus 11 is 24. From the 24 balls, you have to select 3 balls. See. So 24C3 is 2024. So number of possible cases is 1 from red. So how many red balls we have? 5. So 5 from 5 you have to select 1. So 5C1. And 1 blue ball. So from 8 balls you need to select 1. So 8C1. And 1 white ball. From 11 you have to select 1. So 11C1. This is the possible cases. So number of possible bases by number of exhaustive cases, you will get this. Coming to the second bit. Second bit is this one. 2 whites and 1 red. The exhaustive case will not change. It will remain like this. 2024 is the exhaustive cases. It will not change. Only the possible cases will change according to the bit wise. Now number of possible cases is 2 white balls. So 11 white balls are there, from which we have to select 2 balls. So 11C2. Here. And 1 red ball. From 5 red balls you need to select 1. So 5C1. So this is possible case. Number of possible cases per number of exhaustive cases, you will get the answer of the second bit. Now number of possible cases for the third one is 3 are whites. 3 have to be from white. So 11, there are 11 white balls, which 3 you have to select. So 11C3. So total required probability is that one. From number of favorable case by number of exhaustive case by number of favorable case. So this is how you will find the problems on the probability, some of the important problems. So please listen again if you don't understand anywhere or anything, or please drop a comment. If you don't understand, I will surely give you reply. Thank you for watching. Please do subscribe, like and share my video. That's all for today. Thanks for watching.